So 3, 2, 1 is all about increasing, decreasing intervals and extrema. Increasing and decreasing is based off the derivative. If the derivative is positive, f is increasing. If you notice, it says the derivative is positive, and this says just f, not f prime. Okay, if the derivative is negative, f is decreasing. If the derivative is equal to 0 at any point, the original function is constant. Okay, so if you look at this example here, the red is the original function, the blue is the derivative. Okay, and they're graphed on top of each other here. And as you can see, where f is increasing from left to right, so from negative infinity to whatever this is right here, negative 1/2 maybe, and then from 1/2 to infinity, you'll notice that the blue is positive. If you notice, this value right here is positive, the y values. And the y values in this case represent the derivative. Here, the y values are also positive. But if you notice below the x-axis, so the bottom part of this parabola right here, it's negative. While it's negative, that f equation, the f graph, is decreasing. Okay. Now, wherever it's equal to 0, if you notice the derivative is equal to 0 here, you'll notice on the actual graph, it's a horizontal tangent line. Look at that. That's insane. Over here, horizontal tangent line, that means the slope is 0. Look at the blue, 0. Okay, next it says where f prime changes from positive to negative, that's called a relative min. So right here, if you notice the blue, it's going from positive, 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 it's 0 here, and then it becomes negative. Where that switch happens from positive to 0 to negative, there's a relative max. So if you notice right here, there's a hill. Okay. Here, where the derivative changes from negative to positive, and there's a 0 in between, right here it's negative, the blue is negative here, and then it goes up, it's 0 here, and then it's positive, you'll notice the original equation is a relative min. You have to understand that. You have to understand how to use derivatives to find relative mins and relative maxes. Okay, they're called relative extrema because they're extreme values. It's either the extreme high or the extreme low for this. Relative means relative to what's around it. Absolute is when it's the absolute, biggest or absolute smallest. Okay, but these are relative mins and maxes. Okay, critical numbers happen when the x values of whatever x values there are, if the derivative is equal to 0 or undefined. Okay, f of c must exist at each critical number. Okay, if f of c does not exist, then you don't have a critical number there. Okay, so like an asymptote, there's not going to be a critical number because it's an asymptote. Right? You can't. You're just not going to have a derivative of 0 or undefined. I mean, I guess you could have it of undefined because there's no derivative there, but it's not going to actually have a critical point because the point isn't there. Right? There's no x value there. Okay, so right here, this would be a hill. And as you can see, it's actually undefined because it's a sharp turn, but you can use the derivative for sharp turn to find what this value is. Down here, this is a valley. It's not a sharp turn, it rounds off, but it's still a relative min. So even if it's a sharp turn, it's still a relative max. So it could be a sharp turn, or it could be, soft turn. Okay. Are there any questions on that? Okay, next. All relative extrema occur at critical numbers, but the opposite is not necessarily true. It would be a sometimes. Okay? It says all relative extrema occur at critical numbers, but not all critical numbers have relative extrema. Critical numbers means the derivative is 0. So if you look at this first equation right here, this is just x to the third, by the way. If you notice right here, there's a tangent line of 0. But is there a hill or a valley there? No, it just flattens out. So it increases, constant, and then increases again. There's not the increasing to decreasing. And if you remember what I said before, the relative mins, if you look at the bottom part, where the derivative changes from negative to positive, there's a relative min. So there has to be the decreasing to increasing for the relative min. Here, it doesn't do that. The blue just increases to increases. This is not the derivative, by the way, it's the original. All right, over here, there would be a critical number here, even though there isn't because the point doesn't exist. So, but if you notice, this is going from decreasing to decreasing, so it's not really anything anyway, but if I could have made an asymptote that increased to decreased, either way, there's no hill or valley. Okay? Even if there's a certain critical number somewhere, it does not mean that there is a relative extrema. So it works one way, but not necessarily the other. You have to understand that. And I'm going to show you how to test those intervals to make sure that it actually is a relative extrema, but you always have to test the intervals. Some people find the critical numbers and then they walk away. They don't actually test whether it actually did go up or down or up. Okay, absolute extrema can occur at endpoints. Okay, that's one thing that you want to check every single time is the endpoints. I have an example problem that we're going to do today where I show you how you have to test the endpoints. The endpoints do not have a derivative. Can someone explain why endpoints do not have a derivative? Endpoints are like this thing here. Yeah, they stop. They're not changing from one thing to the next. Also, does anyone else have anything else to say? Yes. Yeah, the derivative has to match on both sides because the derivative is based on limits, like he said. So there is no other side to it, so you can't do the derivative at the endpoint. But you can still just test the endpoint by throwing it into the function. And I'm going to show you what that means today. Okay, this is a review from Algebra 1, but you have to understand relative mins and maxes, absolute mins and maxes. Yeah, basically this top graph right here. If you can have one that's an absolute and relative min, as you can see, it doesn't go any lower than this one right here, but it's also at a valley. So it's a relative and absolute min. Up here, this is the absolute max. It doesn't get any higher than it. It's always based on the y value, by the way. As you can see, this is the lowest y value right here. And then up here, it's the highest y value. Here, it's still a relative min because it's a valley. Here, it's a hilltop, so it's a relative max. Here, it's nothing. This endpoint is nothing. It's not an absolute min or max, and it can't be a hill or a valley because it's at the end. Lots of terms, and I'm going to kind of repeat this every single day, so it kind of starts cementing in your head. But if you did watch those videos and you took notes on them, you should know all this stuff. Okay, 3, 2, 1 is all about increasing and decreasing intervals. Okay, and how the derivative can help us find those increasing, decreasing intervals. If you know where it increases and decreases, you also can figure out relative extrema, which is crazy. All right, so number 1. Let's say that we have a function equal to ln x over x. I want to know, I want you to find all the, let's just find all the relative extrema. I'm just going to tell you right now that AP does not make you find all of them. They make you find one of them. Like, just find the relative mins. Just find the relative max. I'm going to actually make you find all of them because this is just practice right now. Okay? We're going to do this one together because this is going to be throwing you in the deep end otherwise. I just want to make sure you understand it. And now, if the first derivative will tell you increasing and decreasing, what's the first thing I should do whenever I do a problem that asks for relative extrema? Find the derivative, okay? This whole unit is all about the applications of derivative. So if you're not finding the derivative on one of these problems or the derivative's not given, then you're doing something wrong. All right, so we're going to do g times f prime. So this is just a review of last unit. Minus f prime g. This is embarrassing. G f prime. F prime. Wait, that's really wait, hold on. G f prime. Minus what? No, is this a limit problem? Very good question, but is this a limit problem? No. Yeah. Don't get that tripped up. All right, minus f, there we go, g prime. All of this is divided by x squared. Now, the relative extrema is found generally using critical numbers. So what you're going to want to do for this is find the critical numbers. And how do you find the critical numbers? You take the derivative and you set it equal to what? 0, and then you solve. Let's simplify this out, though, because it makes this a lot easier. So this and this is going to become 1. This one is meaningless. So you end up with 1 minus ln x over x squared. And we're setting this equal to 0 or undefined. Okay? Always write 0 or undefined. 90% of the time it's going to be a 0, but AP purposely puts one on there that's going to be undefined, and because they know that people forget about it. So make sure you write 0 or undefined, because that's the definition of a critical number. It's where the derivative is equal to 0 or undefined, and it's whatever the x value is. All right, for the 0. So I'm going to do the 0 one over here. All you have to do is worry about the numerator. You do not need to worry about the denominator. For the undefined, all you have to do is set the denominator equal to 0, because then you're dividing by 0. And when you divide by 0, it's undefined. All right, solve this out. What do you get for the 0 critical number? I know, logs, everyone's favorite thing. Someone at home, just chime in, unmute, yell it out. We don't even need to raise hands. Oops. X is equal to E. So we have one critical number. This is amazing. Okay. Our other critical number is pretty easy because it's just you square root both sides, you get plus or minus 0, which is just 0. So now we have where the derivative is equal to 0 or undefined. But we still don't know where the derivative is positive or negative. But we know the instances where it could be shifting, because 0 from one end to the next, it could be positive and negative. So what we need to do next is make what I call a critical number line. Now this is kind of made up by me. This isn't like, you're not going to see a thing called a critical number line anywhere. I highly advise doing it this way. But you just make an x-axis, and on the x-axis, we're going to positive and negative infinity. There's no boundaries for it. But we're going to put both critical numbers. It is critical that you put the critical numbers in numerical order. Some people mess this up. So the first one has to be 0. The second one has to be E. If you mix these up, it's really off, because E is like 2.71828, blah, blah, blah. And 0 is obviously 0. So E has to be greater. Make sure it's on the right. And what we're going to do is we're going to test each of these intervals. So we're going to test the interval right here. We're going to test the interval right here. And we're going to test the interval right here. And the way I like to do it is I like to write the derivative here, and then what the derivative is meaning for what the original function is doing. Okay? If you do this a different way, like say you use a table, or say you use some other way that you found online, that's totally fine. However you want to do this, that's fine. I know some of you teach yourself this stuff. But I advise doing it my way because I've been teaching this a while and I feel like this is the best possible thing. And I'll show you why. All right, so now what you need to do is we're testing the derivative in this interval here. So less than 0. So what we need to do is find our derivative. Where is our derivative? Right there in orange. So can someone give me a value that's less than 0? That's a good value to put into this thing right here. -1. If you plug -1 into that orange equation right there, what do you end up getting? What's ln of -1? Can you have the ln of a negative number? No. So because of that, this whole part right here, I'm just going to put a big X in there. And I don't mean an X variable. It doesn't exist over there. Okay? You cannot do the ln of a negative number. It doesn't really make any sense. If you graphed it, you would see that as well. But ln is the inverse of e to the x. And anything that's e to the x, it can't be negative. Okay? E to what power is negative? It's impossible. Unless you use imaginary numbers. I figure someone's going to say something like that. You can use imaginary numbers. I just thought of Euler's formula. But there is no imaginary numbers in calculus, so we don't need to worry about that. There's nothing there. Does not exist. Now we need to pick a number between 0 and e. What's a good value that's super easy to use that's between 0 and e that we can plug into this derivative? What? 1. Very good. So what is 1 minus ln of 1? What's ln of 1, first of all? E. Not what? No. 0. So 1 minus 0 over 1 is 1. Now, we do not need to write the value, but you need to write the sign. Okay? So 1 is positive, so I'm going to put a little positive here. Okay? Now, if the derivative is positive between 0 and e, what is f doing? Someone just yell it out. Come on. Increasing. Thank you. So now we know that it's increasing right here. Okay, here it doesn't exist. So I'm just going to put another x there. If you don't believe me, you can look at the original function. You can't put a negative in for x here, so it wouldn't exist there either. All right, now what is a good value to plug in for this interval here? It's got to be greater than E. Anybody? 3, okay. I like putting infinity in there because infinity is really easy to do. But so you do 1 minus ln of 3, I don't know what that is, divided by 9. So ln of 3, what? Is it? No, it's not 0. It's going to be some weird decimal. Well, here, let's just do infinity because it's going to be easier. What's ln of infinity? Infinity. The 1 minus infinity over infinity squared is going to be negative over a positive. So that means over here, it's going to be negative. Okay? Another way of doing it, I just thought of this, is if you did plug in 3, after E, it becomes positive, right? ln of E is 1, and then after E, it's positive. So ln of 3 is positive, right? And it's greater than 1, I should say, too. So it'd be 1 minus something greater than 1 is technically negative on the top. So if you want to think of it that way, you can. The issue with that is we don't really focus on net logs that much in this for whatever reason. It's not taught a lot in advanced algebra, which it really should be. But anyway, it's negative. Does everyone see why it's negative? Because that's kind of a big deal. I'm going to write it down just in case someone's not being completely honest. So if I did 1 over ln of infinity, here, let's just do like a huge, huge number. Forget infinity. And then we're dividing it by that huge, huge number squared. You don't care about what this value is. The thing you care about is the sign. And hopefully you see that it's 1 minus a huge number is negative. The bottom is positive. Negative over positive is negative. Does that help? When in doubt, just throw a huge number in there or infinity. Yes. Yeah, you're a little ahead of us, but yes. All right, now if the derivative is negative, what does that tell us that f is doing? Decreasing. So now what you can do, check this out, because we just made a critical number line here, we can sketch what the graph kind of looks like. It's obviously not going to be 100% looking like this, but it's going to kind of look like this. It doesn't matter where you start here because we don't really know where it starts, but it's going to increase. It's going to hit 0 here. We know that it hit 0 because of right here. It's a critical number. The derivative is equal to 0. We already figured that out. That's another thing that I should point out. Never plug in the critical number. You already did that. You know it's 0. You have to plug in something greater than the critical number or between critical numbers here. All right, so anyway, it ends up increasing here, zeroing out here, and then it decreases here. And it has to decrease forever. How do I know that it never comes back up at the end? Yeah, you're all right. Yeah, there is no other critical number, so it never even reaches 0 again. How can it reach positive if it never even reaches 0? Right? It's going to be negative for the rest of its life, whatever it's the rest of it, for all time, it's going to be going down like that. Now, what's cool about this, I just graphed that. Now I can kind of see what's the relative extrema there. E. It happens at E. Right? This is clearly a hill. So this is going to be a relative min or max? Max. Okay? It maxes out at the top. We have to go with what he said first by plugging in the 0 for the endpoint, which you can't because it's undefined. Yes, it would be the absolute max because it's only increasing from this. So yes, you're right. Good call. Way to understand the concept. Did you watch the videos? Could tell. Or you just came up with that yourself. Either way, that is very brilliant. You should definitely be patting yourself on the back for that one. No, I'm serious. He made a really good point. If it's only increasing over here, it's never increasing anywhere else. That's the biggest that it could be. So that is also the absolute max. So absolute and relative max. Now, is there a relative min anywhere? Is there a valley anywhere? We have a hill, but is there a valley? No. So there is no relative min. That happens. Okay, is there a absolute min? No. It goes down forever. It can't, it's never going to min out. Okay? All right. So I was only asking for relative extrema. He added the absolute thing, which is awesome. I got to write that in my notes to use for next year because that is a very good idea. But the answer for that one, for the relative extrema, the x value is E. So I'm going to write relative max occurs at E for the x coordinate, but what's the y coordinate? Is there any way to figure that out? Yeah, you put E in this formula right up here. This is your y formula right here. F of x equals ln x over x. So what's ln of E? 1 divided by x is E, so the answer for this one should be 1 over E. And that's the final answer. There is no relative min, you don't need to write anything down. If it did ask for absolute max, you could write that down as well. Absolute and relative max are the same point. Now I'm going to show you how to do this on your calculator because, I don't know, I just think it's good to do. Actually, don't worry about using your actual calculator. I'm going to show you in Desmos. That would be a problem where you're not allowed to use your calculator. I'm going to show you why. Because all you would really have to do, oops, that's embarrassing. All you would have to do for this one is do this, and look, it finds the relative max for you. As you can see, it goes down forever here. It never goes past 0, which we talked about before. It doesn't exist on the left of 0. To the right, it's always decreasing. There's no other hills or valleys, and you end up with the answer right there. I kind of talked about this a little bit yesterday. All this calculus stuff we're going over, it was before there was graphing calculators, so it was a big deal in like Newton's day, or before there was graphing calculators, really. And if you do this, check this out. So it's E comma 1 over E. Hold on, that's embarrassing. E comma 1 over E, there we go. If you notice, it's right at that spot. Okay. 1 over E is that 0.368. Okay. So maybe thinking, why don't we just use the calculator and do this? Yeah, that would be nice. Check this out though. Desmos allows you to do this. So does your actual graphing calculator. But you can just graph the derivative right on top of it. What I like to do is make it kind of like, I don't know, dashed, so you kind of decipher between the two a little bit. Never mind, I don't like it for this one. What I'm going to do is just turn off the original and just keep the derivative on there. And if you notice, the derivative is equal to 0 right there at E. If you notice, the x value is E and the y value is 0, which is exactly what we wanted. Okay. Any questions on that? AP knows when you can use your calculator to find these things, so it purposely says no calculator for a problem like this. I'm going to do the same thing because that's an AP class. But you might be thinking, I could do this whole thing without calculus. You're right, you can. It's great. But unfortunately, you have to go through those fun steps.